Okay, so today we are doing section 10.6. Your quiz is on Wednesday. This is the last section that is on that quiz. And we are going to talk about the volume of prisms and cylinders. Right, so the first thing, the volume of a prism is going to have a base area B, and the height is H. Remember that the volume is going to be the area of the base multiplied by the height. So this is what type of prism? The first one. Triangular. So then when you're finding the area of the base, you're going to do 1/2 times base times height. Okay? If you have a rectangular prism, then you're used to seeing the volume as length times width times height, which makes sense because the length times width is the area of a rectangle. So it still comes from this. It's just the area of the base is your length times width. Now, the cube is similar. You could still do length times width times height. The only difference is with a cube, you know that all of your lengths are the same. So it's just quicker if you take that length and you raise it to the third power, which would be the same thing if you did length times width times height. Okay, so s times s times s, or s cubed. So for example 1, we're going to find the volume of each prism, and then we're going to round to the nearest 10th. Okay, so looking at our picture for A, we can tell that this is a rectangular prism. So we're going to do the length times the width times the height. Now, it really doesn't matter what you call the length and the width because you're multiplying. And whenever you're multiplying quantities together, the order that you're multiplying them does not matter. Okay, so you're going to do 13 times 3 times 5, and then you would get 195 centimeters cubed. So now that we're doing the volume is something that is in 3 dimensions. So your centimeters are going to be cubed, or to the third power. All right, and then for B it's a cube with an edge length of 15. Okay, so Hope, how can I calculate that? Yeah, okay, so I can just cube 15. Okay, which is the same thing as 15 times 15 times 15. And you will get 3,375. And that's going to be inches cubed. Okay, don't forget to put your units on there. Okay, so far those are pretty straightforward. Now let's move on to the volume of a cylinder. Okay, so with the volume of a cylinder, you're going to have the volume, again, equals the area of the base times the height. Or, because a cylinder has a circular base, you can think of that area of the base as pi r squared. Okay, so because the base is a circle, we know that the area is going to be pi r squared. That's where that equation comes from. It's a pretty good freehand circle for me. Alright, so then we're going to find the volume of this cylinder below, and then we're going to give our answer in both terms of pi and round it to the nearest tenth. So remember that your height is going to be marked with a right angle. So looking at this photo, I already know that my height is 14. And then, Jacqueline, what's my radius going to be for this? Yes. So you have to do half of the diameter, which is given. So then for the volume, I'm going to do pi r squared times h. So pi 9 squared times 14. Okay, we know that 9 squared is 81, so we can just multiply 81 by 14. And Jana, what do we get when we do that calculation? did you get 1,000? Yeah. Okay, good. So 1,134 pi, and then of course that's going to be inches cubed. And then it says we also have to round to the nearest tenth. So I'm going to use the pi button in my calculator. So it'd be 3,562 point, what's my decimal going to round to? Yes, okay, 0.6. And then again, that's still inches cubed. Alright, we're going to explore what happens when we change dimensions. So the radius and the height of this cylinder are multiplied by 2/3. Describe the effect on the volume. Okay, so I'm going to show you how you can find this using the original volume and then the new volume, and then I'm going to show you a shortcut, okay? So if I'm going to find the original volume, I'm going to use the volume equals pi. My radius is given as 24, and then the height is given as 33. Okay, and I'm just going to leave this in terms of pi. So if I do 24 squared and multiply that by 33, I'm going to get 19,008 pi. Okay, now I'm going to do the new volume. So to calculate the new volume, I have to multiply by 2/3. Okay, so first I'm going to do the radius, which is 24 times 2/3. So if you're multiplying, let's do this without a calculator. Okay, so 24 times 2/3 is like you have 24 over 1. 24 times 2 is 48. How many times does 3 go into 48? How many times does 3 go into 48? 16. So this will be 16. Okay, that's going to be your new radius. Okay, and then I'm going to find the height, which is 33 times 2/3. Now another way you could do this in your head is see how you have 33 divided by 3? What's 33 divided by 3? 11. So it's 11 times 2, which is 22. Okay, you could also multiply by 2 and divide it that way. Okay, so that's going to be your height. So now when you're trying to find the volume, you are going to have the volume equals pi 16 squared times 22, which is going to give you 5,632 pi. All right, now to find the effect, we have to find the what? Good, the ratio. Okay, so we're going to do the ratio. Okay, of the new volume to the old volume, which would be 5,632 pi over 19,008 pi. Okay, so the pi's are going to cancel out. Okay, when I'm reducing this, I would try first to see if 5,632 goes into that evenly. Does it go into it evenly? No. Okay, so when you do 19,008 divided by 5,632, okay, you don't get an even number. So then the next thing I would do is divide by something that I know goes in there. What do I know has to go into both of these numbers? 2, so I can cut them both in half, right? So if I take 5,632 and divide by 2, what do you get? Good. And then I might also try to divide by what? Yeah, so if I know 2 goes in there, I might try 4. How can yeah, how can you tell if 6 goes in there? Or 3? Mm-hmm. Yeah, so 5 plus 6 is 11. This would be 11 plus 3, which is 14. And then 15, 16. So I know 3 wouldn't go in there, so I know that 6 wouldn't. So I might divide, see if 4 goes in there. Okay, so it does go into the top. Let's see if it goes into the bottom. Yep. Okay, so if I divide them both by 4 to reduce, I get 4,752 over, or sorry, that's on the bottom. And the first one I found goes on the top, the 1408. Right? And then I'll see if 4 goes into both of those. So it does go into the bottom. 1408 divided by 4. Yep. So I divide by 4 again. So I get 352 over 1188. I would divide by 4 again and see if that works. And it does on the top. Let's make sure it does on the bottom. Okay, now of course you could try bigger numbers. But if you know that some of the smaller numbers are going to work, you can keep reducing that way. Now I'm at 88. What are numbers I know go into 88? Okay, I know 11 goes in there, and what else? 2, 4, 8. Yeah, 2, 4, 8, right? Okay, so the bottom number is 297. What do I know is not going to go into 297? 2. So I know 2, 4, 8 are not going to go in there because they're not even. So I am going to try to divide that by 11 since I know 11 goes into the top. So does 11 go in there? Yeah. Yep. How many times? 27. Okay, so this is your reduced fraction. Okay, so the effect is that the volume is 8/27 of the original volume. Okay, so I'm going to write that on the side. The new volume is 8/27 of the original. Yes, do you notice what ratio it is? Does anybody notice what the significance is of that 8/27?
It's 2/3 cubed.
Okay, yes. So if you take the original, the 2/3, and you cube it, okay, so I'm just going to write here too. You could also say that the volume is multiplied by 8/27. That would also be acceptable along with this. Okay, so this is the factor cubed. So if you do 2/3 to the third power, 2 cubed over 3 cubed, 2 times 2 times 2, 2 times 2 is 4, 4 times 2 is 8, 3 times 3 is 9, 9 times 3 is 27. Okay, so you can use that as a shortcut. You can just cube the factor. Now, that's for when, what happened? What was multiplied by 2/3? The height and the radius, okay? So it's when both of those dimensions were multiplied by 2/3. Okay, let's think about why this makes sense. When we were doing this before with the area, do you guys remember the pattern for the area? It was squared, right? And then the perimeter is just the same as the scale factor. So you know how area we measure in units squared, you square it. Volume we measure in units cubed, you cube it. Okay, so that is what the pattern is going to be. All right, and then I'm going to give you the rest of the time to work on your homework. then, we are gonna do an on-task check today, so to get full points for your on-task check, you just have to make sure you are working on your homework to the bell. If you finish your homework, then please come up and show it to me, and then you can either work on another class or read. Okay, but in order to get your points for your prep check, you need to be working on your homework, and you're staying in your seat and working on that until the bell rings. Oh, thanks, page 739.